Regardless of whether we're dealing with a sine curve or a cosine curve, both of those fall into the category of sinusoidal curves. So you'll notice I created myself a sinusoidal curve here with no axes so that we can't really tell whether it's a sine or a cosine. It doesn't really matter. What we're going to do is define three different geometric aspects of the sinusoidal curve so that when we start graphing these using transformations, we can identify what algebra is associated with what. So first thing I'm going to put on here is referred to as the midline. The midline is the horizontal line that lies halfway in between a maximum and minimum value. A horizontal line halfway between a minimum and a maximum. Now, if you're ever interested in calculating a midline and you happen to know what a maximum value is and what a minimum value is, then adding them and dividing by 2 would give you that. So maximum value plus the minimum value and divide that by 2. Now, we are talking about y values, not x values. So, next thing that we'll introduce is the vertical distance from the midline to a maximum, or the vertical distance from a midline to a minimum. Given that the midline is halfway in between them, those two distances should be equal to each other. That distance is referred to as the amplitude of a sinusoidal curve. This is the vertical distance from the midline to either a maximum or a minimum. Now, based off of this definition, if you happen to know the maximum and minimum, then technically you could calculate the amplitude by doing the following. That would be the maximum value minus the minimum value divided by 2. Now, if you already know the midline, though, you can simply do the maximum value minus the midline, or the midline minus the minimum value, and that would give you an amplitude as well. Oh, excuse me. I swear it's not COVID. I just ate a lot of pizza, and it's scratching my throat. It's delicious. In fact, I'm going to take a break and drink some of this water right here. And of course, the water's going to be way too cold, and that's going to make me want to cough more. Good times. All right, so third thing is going to be the horizontal distance from either a maximum to a maximum or from a minimum to a minimum. In mathematics, we know this to be one period. However, it also gets discussed at length in physics, and they tend to go with the term wavelength for one of those. This is the horizontal distance from a maximum to a maximum, or from a minimum to a minimum. Now, technically, it could also be from a point on the midline where it's increasing to the next point on the midline where it's increasing, or we could also do point on the midline where it's decreasing to point on the midline where it's decreasing. However, what you cannot do is point on the midline to the next point on the midline. That would only be a half period. Now, for the mother functions that we have, for y equals the sine of x and y equals the cosine of x, I'd like to identify all three of these quantities. And for that, I'm going to reference something from our last video, which is the graph of y equals the sine of x. Additionally, on the back of this page, we also have y equals the cosine of x. And in both of these cases, the midline is going to be y equals 0. The amplitude, which would be the distance from the midline to a maximum or a midline to a minimum, was 1. And finally, the period is equal to 2 pi, since they repeat themselves every 2 pi units. So I want you to keep this in mind as we move forward, because these three quantities are a great way to map out the plan for graphing using transformations. Oh my gosh, I'm so sorry that I said that.